In this video, we'll take up the homework questions on factoring difference of squares and perfect square trinomials. So for the first question, you basically have a bunch of difference of squares. Just be careful. I would recommend you to common factor first and then look for your difference of squares. Just like number one, you actually have a difference of squares, but it's easier if you common factor first. Not that you can't do it the other way around, it's just, I would say it's a little more time consuming if you do it the other way around. But you know what, as long as you get the right answer at the end, it's fully factored, then you get full marks. R is not factorable because it's 169w cubed, so it's not a perfect square there. W cubed is not a perfect square, so there's nothing you can really do with that expression. Okay. For W, you can actually keep going, but you don't know that technique. In fact, you don't learn it this year, so just leave it alone. It's actually a factoring technique called difference of cubes, but you'll learn that in grade 12. Okay. For number 2, let's see. Number 2, we are just looking at some binomials for A through E. For A through E, you're just looking for common factors. There's common factor F. For I, there's really nothing you can do. Between the three terms in I, there's nothing you can do. No common factors. Yeah, so just leave it as it is. So a lot of common factors here. Yep. Oh, for M, you have a common factor, and then you can further factor because you have a complex trinomial that's factorable. So this one, you can't do anything. So yeah, beautiful. Let's see what happens for T. Yeah, T is not factorable. So I have some fancy writing or fancy terminology here. Just write not factorable for now. And I'll explain why I wrote not factorable over the rational numbers. Okay. And yep, there's really not much to say for question 3. If you see a perfect square trinomial, well, first of all, remember, you should suspect you have a perfect square trinomial if the first and last term are perfect squares. So that's basically what I noticed when I saw those expressions. After I see that the first and third terms are perfect squares, then I check the middle term, see if it's equal to 2ab, or yeah, see if it's equal to 2ab, and then if it's not, then it's not a perfect square trinomial. Like for G, 3G, it's x squared plus 5x plus 49. So the first and last term are perfect squares, but the middle term is not equal to 2ab, so it's not a perfect square trinomial. All right, so that's basically it for the unit.